welcome you all for this celebration on 8051 microcontroller simulation part. To start with, as I already said, it is mandatory for us to look at the data sheet, right? So whenever we take the data sheet or whenever we want to study the microcontroller, it is mandatory for us to look at the data sheet, and it is mandatory to look at the first page of this data sheet. Say for example, first page will have some features. So here you can see that Atmel flash microcontroller. The features given are 8-bit CPU optimized for control applications. Meaning 8-bit CPU means what? If you look at this block diagram here, so there is a CPU. Look at this block diagram, look at the cursor. There is a CPU, which is 8-bit CPU, which is a microprocessor. So optimized for control applications means, as discussed, control means on and off. To switch on and switch off, all the parallel ports are bit set resettable. Because all the parallel ports are bit set resettable, there are 4 ports and each ports are bit set resettable. And why CPU is optimized for control applications means there are Boolean operations. There are Boolean instructions available. Because of the Boolean instructions available, we can control the individual bits of the corresponding microprocessor. That is why it is called as 8-bit CPU optimized for control applications, that we must understand. So that is what the thing which is extended in the second point, extensive Boolean processing capabilities. So this extensive Boolean processing capabilities means single bit logic. So single bit logic can be programmed. That means we can do arithmetic and logical operations over bit instead of byte. Okay. So on-chip flash program memory. There is something like on-chip flash program memory. As we know, there is a rainbow. Rainbow means 7. 7 means microprocessor plus 7 mandatory, 6 mandatory peripherals. So the first primary requirement is read-only memory. Read-only memory inside the microcontroller is called as flash memory. And we have on-chip flash program memory, which is shown, which is read-only. That's why the arrow mark comes outside. The arrow mark is not going inside from the flash memory with respect to 8051. And there is an on-chip data RAM. So here there is an on-chip RAM, which is bidirectional as shown in the block diagram. So program, that is microprocessor, which is CPU, the program memory or flash memory, and the data memory or on-chip RAM is more than enough to do all the computations. But if the user need to interact with this microprocessor based system means we need a port, yes or no? So there is a parallel port here. So that is what is shown here next to flash memory and RAM, bidirectional and individually addressable IO lines. So what do you mean by bidirectional? So port can be an input port, port can be an output port. Individually addressable means, as discussed, right? Every port bit is addressable. So P0.0 is addressable, P0.1 is addressable, etc. That is why addressable IO lines. So port as well as general purpose input output, both are same. Okay. So addressable IO lines. Addressable IO lines means it denotes parallel ports only. So here there are four parallel IO ports in the block diagram. So port 0, port 1, port 2, and port 3. All the 4 parallel ports are bidirectional, and it is shown here. All are 8-bit ports because 8051 microcontroller is an 8-bit microcontroller. Hence, all the four ports are 8-bit ports. Hence, there are 32 GPIO lines. All the 32 GPIO lines are bit set resettable, something like this. Next to the parallel port, multiple 16-bit timer bar counter. It is given as the top right corner of this block diagram. I am just showing here. So there is a multiple 16-bit timer or counters. There is timer 0 and timer 1. There are 2 timers with respect to 8051. Both are 16-bit. Timer bar counter. Today's topic of discussion is timer. Today we will wind up with the timer. That is more important. And there is a full duplex UART. There is full duplex universal asynchronous receiver transmitter. So we'll be discussing about the serial port soon. So which is the most important topic. Mostly by Monday we'll be discussing about it. Maybe at least you should invite more people to discuss about the serial port, which is more fantastic and more important. Okay. So there is a serial port. That means on UART, because it is a serial port, only one single line. That is why there is a TXD line, single line comes out, which is transmit data. One single line goes in, which is RXD. So TXD is transmit data, RXD is receive data. So whenever there is a UART means TXD and RXD are the 2 pins, which is transmit data and receive data. So whenever there are 2 pins, then we can say it is full duplex, because there is a separate transmit line, separate receive line means, then just like that we can say it is a full duplex serial communication. And next to serial communication, if you look at the features, multiple source or vector priority interrupt structure. So there is an interrupt structure. As told, there is an interrupt structure. So multiple source or vectored or priority interrupt structure. If you look at the top left corner of this block diagram, so there is an interrupt control. So there are two arrow mark which is horizontally coming towards it, meaning there are three software interrupts in 8051, and there are two arrow mark which is coming from the top, which is hardware interrupt, which is called as external interrupt, which is INT0 and INT0 bar. So from this discussion, our rainbow has come because microprocessor plus 6 mandatory peripherals has been discussed. So quickly to look at the block diagram, there is a microprocessor, there is a read-only memory called on-chip flash memory, and there is a random access memory called RAM or data memory, and there are parallel ports, 4 parallel ports, which is called as GPIO, and there are two timers, timer 0 and timer 1, and there is one serial port, and there is an interrupt controller which has 3 software interrupts and 2 hardware interrupts. So each module is having its own significance. We'll be discussing those things in detail today. Sorry, not today, in the following classes. But we must know microprocessor plus all the mandatory peripherals are in a single chip, which is called as microcontroller. It is one definition. And microprocessor plus all mandatory peripherals in a single chip and specially designed for control applications is other definition. Control applications means switching on and switching off applications. That is what the thing which you need to understand. So when we start understanding any microcontroller, it is mandatory to look at the data sheet, that too first page of data sheet. Here in the first page of data sheet, we have discussed the first 7-8 points, and the other few points saying that on-chip clock oscillator and on-chip E-square PROM, SPI bus, watchdog timer, etc. This is 8089 series available, so we'll be discussing that in detail. But the primary mandatory things, those 7 peripherals are there that has been discussed, because we are keep on saying the microprocessor plus 7 mandatory peripherals are called as microcontroller. Through this, it is being justified. So the block diagram we need to understand, which is very clearly understood from this data sheet. So data sheets are the best material in the world. That is why I am just discussing with the data sheet. So after discussing this, we should go for the program memory. Look at the screen. In the screen, we have a program memory. So there are internal 4 kilobytes of program memory, and it can be extended to 64 kilobytes. That is what is shown here. So in the figure 3, if you look at the screen, if there is a pin called external access bar pin, I'll show you the pin number, which will be very interesting. So all of us know what is 8051, but the datasheet point of view, learning is primary requirement. You can see. So we are very much comfortable with only dual inline package. So let me zoom the dual inline package pin structure. So this is the pin diagram of our 8051, which has 40 pins. So port that is pin number 1 to pin number 8 is port 1, and pin number 10 to pin number 17 is port 3, 21 to 28 is port 2, and 32 to 39 is port 0. So out of 40 pins, 32 pins are for parallel ports. All these port related things has been discussed already, but quickly I am refreshing this. So here, while discussing about the parallel ports of this, so while discussing about the program memory, here you can see there is one line called external access bar equal to 0. EA bar equal to 0. If EA bar equal to 0 means external memory. If EA bar equal to 1 means internal memory. So internal memory or external memory means what? This is internal 4 kilobytes of memory. That means if we are interested to make use of internal 4 kilobytes of program memory of your 8051 microcontroller, it is mandatory to connect this external access bar pin to logic 1 or VCC. If the external access pin, if it is connected to supply voltage means, then whatever program that we download into the microcontroller, it can enter into the program memory or flash memory of the microcontroller. So why I am highlighting this, because if the external access pin, that is external access bar pin, is not connected to supply voltage, that is not connected to VCC, means even Obama comes, even Bill Gates comes, even Sundar Pichai comes, nothing will work in 8051. That is very important. Okay, so hardware and other things will never give excuses. If the EA bar pin is not connected to VCC, even our Prime Minister Modi comes, nothing will work. Okay, So that's what. So there are so many important things which need to be done. That's why I'm highlighting this. Okay, in the hardware, external access bar pin must be connected to supply voltage. What is external access bar pin? External access bar pin is 31st pin. If you see this in this pin diagram, so the 31st pin is external bus bar, external access bar VPP. This has to be connected to supply voltage. So when this 31st pin connected is to the 5 voltage means, then only the internal program memory can be used. If necessary, we can go for external memory, but no way people are using the external memory. We are more or less, we are satisfying the requirement by using the internal memory itself with respect to program. And the right side, there is another block which is called as data memory. So internally there are 128 bytes of memory, and again there is another 128 bytes which is called as special function registers, and there is one square box which is shaded. So this in 8052, the memory is 256 bytes of internal memory as well as the special function register. Okay. So then the data memory can also be extended up to 64 kilobytes. That is what we can show, we can observe from this diagram as shown here. So from these two diagrams, so program memory can also be extended up to 64 KB, and the data memory can also be extended up to 64 KB with respect to 8051 microcontroller. And if you observe carefully, program memory is also starting at the address 0000, and data memory is also starting at the address 0000, because program memory and data memory are starting at the address 0000. Hence, we can call this as hardware architecture. So hardware architecture means both the program memory and data memory both are separate. Because they are separate, and they are called as hardware architecture. That is what the one important thing which we need to understand from this diagram. All of these things we know very well, but quickly to refresh, I'm just touching upon these points. And looking at that, the whatever program that we write, it can go into the program memory. Whatever program that you write, it will go into the program memory, and whatever program that we write, it will go into the program memory. And we don't want to concentrate much on the program memory right now, but it is mandatory for us to look at the data memory, because whatever the user have access only to the data memory, hence the user need to understand how the data memory works. That is why I'm just touching upon few points with respect to the data memory. If you look at the figure 9 in the corresponding data sheet, so there is a data memory in the left hand side as well as right hand side. You can see in the left hand side diagram, you can see 00 to 7F. So this is the hexadecimal memory address, as we all know. So the data memory is segmented into three. One segment is called as register bank, another segment is called as bit addressable area, another segment is called as general purpose RAM. General purpose RAM means it can be used for simple read-write functions. So, but the register banks as well as the bit addressable area has some specialty that we will be discussing soon in later sessions. So, you can see in the data memory, the register banks, there are 4 register banks: register bank 0, register bank 1, register bank 2, and register bank 3. And each bank has 8 registers, R0 to R7. And bank 0 has registers R0 to R7, bank 1 has registers R0 to R7, bank 2 and bank 3 also has the registers R0 to R7. So 8-bit register bank, something like that we can call. That is why the address, if you see, 00 to 07 is for bank 0, 08 to 0F is for bank 1, 10 to 17 is for bank 2, and 18 to 1F is for bank 3. From 20 memory location to 2F memory locations, these locations are bit addressable. That is why it is segmented like this. Bit addressable means what? The 20th memory location is bit addressable, but 1F memory location is not bit addressable, and 31 memory location is not bit addressable. Bit addressable in the sense, what I can write into this 20th memory first bit. First bit is called as 00 bit, as shown in this figure here. Please look at the screen. I can write into this 20.0. This is called 20.0, 20.1, 20.2, 20.3, 20.4, 20.5, 20.6, and 20.7. And this is 21.0, 21.1, 21.2, 21.3, 21.4, 25.5, 25.6, 21.7. Meaning individual bit can be addressable. So what is there inside this? It is written as 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 5, 6, 7, and again 8, 9, 10, and up to 7F. What is the 7F? What is the decimal equivalent of 7F? Decimal equivalent of 7F is 128. What do you understand from this? The internal numbers, what is there in this memory here? Bit locations, that is bit memory address. You can say this is bit memory address, meaning the first bit address location is 00, second bit address location is 01. That means, as we know, there are Boolean instructions. By using Boolean instruction, we can say bit 1, we can say bit 2, you can say bit 7, you can say bit F, you can say bit 2F, something like that. Means it denotes this particular bit. That is very, very important that you need to understand. That means if it is bit 33 means it is 26.0123. 26th registers third bit 0, 1, 2, 3, third bit is nothing but memory bit location 33. This is bit location. Exactly speaking, this is bit address. So what do you see in the left column is byte address. What do you see within the grid, which is bit address. Okay. So bit address starts at 00 and bit address ends at 7F with respect to the left diagram. Meaning 16 bytes are bit addressable. 16 bytes are bit addressable means from 20 to 2F. The data memory location from 20 to 2F in 8051 microcontrollers are bit addressable. Hence, the address starts from 00 to 7F. So 16 bits are bit addressable means 16 into 8, which is 128. 128 bits are individually addressable. Meaning 128 sensors data can be stored independently in the corresponding locations, or 128 actuator bits can be stored in this corresponding locations, which is more than enough for a 8051 microcontroller, 8-bit microcontroller, which is very clear. And from 30 to some 7F, these locations are left free. Wherever, whenever we need, we can use it. Use these spaces. Use these spaces means what? These are all the spaces used for variables. So when we create a variable in the C program, so it will occupy some space only in some of these memories here, or it can occupy some space in the register banks, etc. While writing the program, I will ensure that. And coming to the right hand side, they are all called special function registers because they are all the status registers or control registers of the on-chip peripherals. Status registers are control registers of the on-chip peripherals. It is not necessary to remember all these things, but the primary requirement is parallel ports. So there are 4 parallel ports as we discussed: port 0, port 1, port 2, and port 3. So port 0 is also a part of memory. Port 1 is also a part of data memory. Port 2 is also a part of data memory, and port 3 is also a part of data memory. That alone we can remember. Fortunately, the address is also easily rememberable. If you look at the right hand side diagram, special function registers diagram, the last row, the bottom row is port 0's address. So port 80, 90, A0, B0 are the 4 data memory locations of 4 parallel ports: port 0, port 1, port 2, and port 3. So because the registers are occupying some space in the data memory, they are called as memory mapped registers. I hope you could have come across this word, memory mapped registers. So the registers are occupying some space in the data memory locations, hence they are called as memory mapped registers. And whatever micro because we are a user, we need to bring out the data from the microcontroller. If there is a processor, if there is a program memory, and if there is a data memory, these 3 are more than enough to do so many things. But as a user, we do not know what is happening inside. If the user wants to see what is happening inside, it is mandatory for us to bring out the data. So to bring out the data, it is mandatory for us to look at the parallel ports. Okay, so now let us look at the architecture of the parallel port, and we can jump into the programming, which is very interesting. Okay. So now I'm going for the another data sheet, which is very interesting. So in this data sheet, the detailed block diagram is there. It is just for you to understand, nothing to remember, but just look at it. So many things which we can celebrate by looking at the data sheet, which is very important. So you look at some detailed block diagram of this 8051 microcontroller, where if you observe carefully, in the top, just I'm highlighting that I'm showing that P0.20 to 0.7, which is parallel port 0, and P2.0 to 2.7, which is parallel port 2. So these are all the pins. P2.0 to 2.7 are pins, P0.0 to 0.7 are pins. So because all the parallel ports are bidirectional ports, so the arrow mark is bidirectional, and you can see port 2 drivers and port 0 drivers. So this is very important. So in the memory discussion, so I'll be sharing the detailed question and answers also. So in the memory discussion, there are drivers. Drivers means what? There are buffers. So internally there are buffers. Drivers means what? There are field effect transistors. I'll show that. Okay, now itself I'll show you. So there are some field effect transistors. This is called as driver. So this is very important because all of you know much about the parallel ports, but knowing this, what I'm discussing now, is very important for you all. That's why I'm just highlighting this. So now you look at this internal structure of the parallel port with respect to 8051 microcontroller. Just I'm zooming it. So this is the parallel port 1. That is parallel port 1 structure of this 8051 microcontroller. And if you look at this diagram, in the right hand side, you can see one square, which is P1.x pin. So this is one of the pin of our parallel port. That is, let us say P1.0. So it has one latch. It's very interesting. It has one latch, which is called as D flip-flop, as discussed in the previous classes, as you know very well. So the latch is a D flip-flop. So from the latch, data enters the pin through the field effect transistor FET driver. So this is called as field effect transistor. Now you must know what is the significance of driver. So driver means it provides, it can source the current or it can sink the current. So we could have studied the fan out and fan in the digital electronics. This fan out means how much current this can drive. That is, this port pin can drive how much current is nothing but your fan out. Through port 1, through this port pin, how much current it can sink, that is nothing but your fan in. So that is very important, as you would have studied already, and if you know much better than that me, you can share it now later. Okay, so driving capability is called as driver. Driving means what? So providing the necessary current to the pin. So because field effect transistors are capable of controlling more, driving more current, that's why field effect transistors are here. So next to the latch, there is a driver, then there is a pin. This is very important, we need to understand. Now you look at the diagram. So which the diagram that what we have seen, now you can see the big block diagram. In this block diagram, we are seeing the drivers, you see, port drivers. What do you mean by port drivers? The field effect transistors are drivers. Below the drivers, there is a latch. You can see port 0 latch and port 2 latch. This is very important, sir. So because this is very important for us to understand. So there are pins and there are drivers. Drivers are nothing but they are all field effect transistors. And there is a latch. Latch means D flip-flop. So whenever microprocessor need to write a data into port 0 or port 2, through data lines, it can select this corresponding latch, and then it can put the data into the port 0, as well as if a microprocessor want to write the data into port 2, means it can put it into the latch, and then it can do the next job. So latch holds the corresponding data until it is re-enabled and rewritten again. So this data which is available in the latch, which can be taken out to the pin through the corresponding drivers, which can drive the LED or which can drive the motor or anything else. What peripheral that we have connected to the corresponding pin, it can drive that corresponding pin. This we need to understand with respect to parallel port. And there are so many other on-chip peripherals. If whenever necessary, we'll discuss about it. Now it is mandatory for us to look at the pin diagram of this. Sorry, the parallel port structure, which is very important, which we do not know much about it. Now I am coming to this parallel port structure of this 8051. This we all know. It is very much comfortable for us to look at the parallel port 1. So here we can see, just now we have discussed about there is a pin and there is a field effect transistor and there is a latch. So along with that, several times we have discussed that all the microcontrollers at reset, it configures itself as an input port. Once again, I repeat, all the microcontrollers at reset, it configures itself only as an input port. Meaning, for the safety reasons. For the safety reasons in the sense what? Whenever the microcontroller is reset, the port has to be an input port. Then data can come into the data memory. Data can come into the data memory. No data can go out. It is mandatory. Why? Because before the program gets the control over the port pin, some junk data in the port pin can drive the corresponding load. It can switch on the load or it can switch off the load before the program gets the control. So it is dangerous. Hence, all the microcontroller manufacturers has configured automatically all the parallel ports must be the input port. That means the provision must be there in such a way that data has to come in through the pin. No data should go out from the latch to the pin. That we must understand. Now I am going to highlight this point. All of you would have studied this, but you must know how this is happening. So now it's time for me to brief about this. This is very important, and this you can celebrate much better. You could have never experienced this, I believe. Now look at the screen. That's very interesting. So when you have, when we look at the parallel port, when you look at the parallel port, if you see the KEIL IDE, so let me say the KEIL IDE, let me say something. Just like that, we don't want to concentrate much about the program, but I'll show you the parallel port structure. You can see. So there is a port 0 and port 2. So in the simulator, you can see there is port 0. The simulator, we can see there is a port 2. I'll keep all the 4 parallel ports for our convenience. Port 0, port 2. I can take the other 2 ports also. This is the very important celebration. So we have never experienced the classes like this. That's what I'm just trying my level best to make you to understand. So there are 4 parallel ports. I hope you are able to see port 0, port 1, port 2, and port 3. So if you observe this 4 parallel ports in the simulator, so the first row is latch. What is this latch? So as right now we are seeing this in the data sheet now. Yeah, right now we are seeing that in the data sheet now. So this latch P1.x. So every port has 8 pins. So there are 8 latches, and there are 32 GPIO lines, general purpose input output lines. So there are 32 latches available that we need to understand. Okay, so there are 32 latches. So this is 8 latch, and here in the port 1, there are first row is 8 latch. Port 2, the first row is 8 latch, and the port 3 first row is 8 latch, which is nothing but the D flip-flop, which was discussed very clearly in the memory structure in the previous classes. And the second row is called pin. Second row is called as pins. So these pins are kept in logic 1 state. So several times it is being discussed. All the ports pins are in pull-up state. Pull-up state means what? FF state. All the port pins are in pull-up state. Pull-up state means what? FF state. FF state means what? It is logic 1. Even if you see in this is the data memory. Fortunately, the memory 2 is data memory, which is being there in the bottom row. Here I can show you. I can show you. Say for example, I will show you the. This is very important. This is very interesting. That's what the simulation I can demonstrate so much of things, so I can make it much interesting. So I am just showing the 80th location. 80th location is port 0 location. You can see. Please look at the screen. The bottom row. The data memory 80 has the value FF. Data memory 80 has the value FF. Why? Because the latch port 0 is having FF. Now if you see, if I change the value here, let me check whether it is possible. Is it changing or not? I am changing it to 00 instead of FF. I am changing the latch content to 00. Let me check whether it is changing. You see, data memory is also changed to 00, and the pin content also changed it to 00. It's fantastic, right? Because port 0 is the data memory 80th location. Now I am changing it to FF. So you will get, you can see, it will become FF. Similarly, you can see 90 in the same row. If you see after some distance, you can see it is a 19th location, 90th location, which is port 1 location, which is FF. Now I am editing this port 1 to 00. You can observe that will also become port 1 value has become 00. Again, I am making it as FF. I am purposefully doing this. Please be with me. All of you know this, but anyway, this simulation can give you much more confidence. So now I am making it as FF, and it has come like this. And again, in the port 2, you can see here, please look at the cursor. This FF is port 2 address, which is A0. So now I'm making this as 0, 0, 0. And you can observe that Here this A0 data memory location as becoming 00. Now I am making it as FF, and all the port pins has become 11. 111111. If it is a tick mark, it is 1. If there is no tick mark, it is 0. So please observe carefully. There is one very interesting concept here. And I'm port 3. What is port 3? B0. This is B0 location. So you can see my cursor. So I'm highlighting this is B. So B, that is port 3 has become 00 now. Now I'm making port 3 as FF. Now port 3 has become FF. So now the magic word or the secret of parallel ports of 8051 I can show. So I have changed all the 4 parallel ports, port 0, port 1, port 2, port 3 as 00, and then again back to FF. But if you observe carefully, except port 0, all the port pins of port 1, port 2, port 3 has become 111111111111. But port 0 pin has never become 1111. It is empty. If it is empty means there is no tick mark. No tick mark means the value is 00. You can see only port 0 pins are 00, but port 1 pins are also FF, port 2 pins are also FF, port 3 pins are FF. This is the magic you want to observe. Whether you have observed or not, once again you can observe it quickly, the data memory as well as this latch. Now I am changing it in latch. The latch is, I am making this latch as 00 of all the ports. You can see all will become 00. All will become 00, 00. I'm going to give some lot of concepts because we are going to study embedded systems also through microcontroller. Just simply discussing about the parallel port of 8051 is not good, but while discussing this, the concepts of embedded systems need to be discussed. That is why I'm doing this. Now look at all the simulation window of all the 4 parallel ports. All are 00. So the latches are also 0. The pins are also 0. Now I'm making this. You can see the data memory. 80th location is also 00, and somewhere 19th location is also 0. A0, B0, all are 0. The bottom row there is no FF. Yes or no? Now I'm making port 3 as FF. Now I'm making port 3. Instead of making FF, I can make it as tick mark. If I click means it will become 1. That is also possible. If you observe this carefully, now you can see this is 7F. You can see this is port 3. 80th memory location is, sorry, 8090. B0's location is, this is B0's location of the data memory, which has become FF. So when I make it as 00, both ports and latches are becoming 00. When I make it as FF, both latch and pins are becoming FF, which is the very important thing with respect to port 3. With respect to port 2, I'm making it as FF. Yes, port 2 or latch as well as pins are also becoming FF. Here also in the data memory, in the A0 location, it is becoming FF. I am making port 1 as FF, which is all ones. Hence, the latch also becoming 1 and the pins also becoming 1. And I'm making port 0 as FF. Here is the magic. In port 0, only latch will become FF, pins will never become FF. So there is a secret here. This is one very important thing we need to understand in the interview. When you go for any embedded system company, the first and foremost requirement is they will ask only these things. They will never ask us how many parallel ports are there in 8051 microcontroller. The parallel port, this is the secret word which is very important to understand. Here, the port 0 is not becoming 111111 because port 0 do not have any internal pull-up resistors. So all other ports, port 1, port 2 and port 3 have internal pull-up resistors. Because of the presence of the internal pull-up resistors, all has become 1. Because there is no pull-up resistors in port 0, that is why it is not becoming 1. That is one of the magic keyword I want to highlight. Now I can show you that in the diagram. You can see this is the bit structure of port 1, where you can see the internal pull-up resistor. Can you able to see the internal pull-up resistor? Because of the internal pull-up resistors, when we make the latches 1, or whether we are making latches 1 means it is becoming 1. If we are making the latches 0 means it is becoming 0. Why and how I will tell you. This is the very important thing which we do not know. So port 1 has internal pull-up resistors. If I scroll down, I can show you. So this is port 3. This is port 3 structure. So port 3 structure is also having some internal pull-up resistors. As we know, there is a latch. and there is a field effect transistor driver, and there is a port 3 pin. Along with that, there is a pull-up resistor. So port 1 have pull-up resistor, port 3 have pull-up resistor, and we can see port 2 also have pull-up resistor. You can see port 2 also having an internal pull-up resistor. So there is a latch in port 2, and there is a pin in port 2, there is a field effect transistor in port 2. Along with that, there is a pull-up resistor in internal port 2. And coming to port 0, this is very interesting. Coming to port 0, there is no pull-up resistor, you can see. Here also there is one field effect transistor. Here also there is one field effect transistor. There is no internal pull-up resistor. Because there is no internal pull-up resistor, it is not pulled to logic 1 state. So the pin is left free. So this is called as open drain. Now you can relate with all the learnings that what you had with your digital electronics and microcontrollers, etc. You could have come across the word open drain. So port 0 is not having pull-up resistors, hence it is called as open drain. Why it is called as open drain? If there is a transistor, you must say it is open collector, because there is a field effect transistor sitting inside as a driver. So field effect transistors are gate, source, and drain. So because the drain is kept open, just like that, because the gate is the drain pin of the field effect transistor is left open, hence it is called as open drain. Please try to understand. These are all very important thing, very precious thing for a hardware engineer to concentrate. If we are an embedded engineer, as we must know both the hardware and software. So to design the hardware, these are all the primary requirements for an embedded engineer or a hardware embedded engineer. Okay, so port 0 is open drain, but port 1, port 2, port 3 are all having internal pull-up resistors, hence it is not open drain. So open drain, what is the significance or advantage of open drain? When it is open drain, it can sink more current. That is the magic. So it is much in depth. If you don't want to go in depth into it, but it is very important to understand. If there is an open drain, it can sink more current. Why port 0 alone is open drain? Why? Because it has a multiplexed address data line. You see, port 0 has a multiplexed address data line. If you look at the pin diagram also to make you to more understanding. If you look at the pin diagram, you see port 0 is very complex. So you can see port 0 is very complex because it can act as an input port, it can act as an output port, it can act as a lower order address line, it can act as a data bus also. So A0 to A7 address line, D0 to D7 data line, as well as it can act as an input port and output port. Because there is a multiplexed address data line, and because there is a data line, lot of data will come from all the external devices to the microcontroller. Hence, it need to sink more current. To sink more current, it has to be open drain. Hence, it is open drain. Fantastic, right? So this is very important and very precious points to be observed or noted in the parallel port structure of our 8050 microcontroller. So I will tell you another interesting story before going to the program, which is very important. Another interesting thing with respect to parallel ports. So till now we never discussed about why logic 1 makes all the port pins as input port. So because of when the latches are logic 1 means, then only it has to be an input port. That's why when the microcontroller is reset, at reset the initial value of all the four port pins are 1 1 1 1 1 1 1. That means FF. Okay, so at reset all the port pins are acting as an input port. For making all the port pins are an input port, all the port pins must be in logic 1 state. Why, how? That is what we are going to discuss it now, which may be boring, but without knowing this, it is very difficult for us to do any programming part. The rest of the thing has been discussed already, but these are the few things which need to be discussed. It's a need of the day. It's a time for us to do this. Now look at this structure. Look at this port 1 is one of the very easiest port because it does not have any other extra things. So in this, let us assume at reset, the latch is logic 1. As now, right now, we have seen in the simulation window also. Because the latch is 1, all of us know that Q is 1. Q is 1. So D is 1, Q is 1. Because Q is 1, if the read latch is 1 means what? So this portion, D is 1 means Q is 1. Q will become 1. If the Q is 1 means what about Q bar? Please look at the diagram, look at the screen, look at the cursor. So D flip-flop is logic 1 means Q output of the D flip-flop is 1. What about Q bar output of the D flip-flop? If the Q output of the D flip-flop is 1, means Q bar output is 0. If the Q bar output is 0, this field effect transistor acts as a switch here. So this driver acts as a switch. So when Q bar equal to 0 means this acts as a open switch. Open switch means what? It is switched off. So if this field effect transistor is switched off, meaning it is open circuited. So because this is open circuited, whatever values are there in the pin, if the pin has logic 1, it can never enter here. It can go into the read pin buffer. When the read pin is active means it can go into the internal bus directly. So because Q bar is in logic 0 state, because field effect transistor is switched off, field effect transistor is switched off means it is open circuited. Hence, what is available in D will never reach the pin. Once again, I repeat, the D, there is a latch. Initially, D has to be 1. When D is 1 means Q will become 1. If Q is 1 means Q bar will become 0. If Q bar is 0 means the field effect transistor's input is 0. Because it acts as a switch, for the gate input 0, it acts as an open switch. Because it acts as an open switch, so it is acting as an open circuit, or it is acting as an open circuit or in high resistance. So then what is there in the pin? What value is there in the pin? If the pin value is 1 means that can go inside through this way. You can look at this screen for the cursor. So what value is there in the pin? It can go inside the internal bus through a read pin as shown here. If the read pin is enabled means data can go in automatically through this tri-state buffer. So very important thing is what is available in D will never reflect in the pin at reset. But what is available in the pin will reach the internal bus. So once again I repeat, what is available in the latch, what value, whether if the latch has 1 or latch has 0, the latch content will not get reflected in the pin at reset. Why? Because the field effect transistor is in switched off condition. Because it is in switch off condition, it is open circuit. Open circuit means D content is isolated from the pin at reset. But there is another path for this pin. What is there in the pin? If the pin has logic 5 volts or 0 volt, it can enter the microcontroller's internal bus. Fantastic, right? So from this discussion, we can say what value is there in the pin which can enter the microcontrollers, but what value is there in the microcontroller will never enter the pin. Hence, there is a possibility for the data to come in, but there is no possibility for the data to go out. Hence, it is secured. Fantastic, right? So how we can celebrate? So celebrate the advancements in digital electronics. These are all the digital electronics, our tri-state buffer and latches and field effect transistors and pull-up resistors, and all of these are all some digital electronics. So the programmable digital electronics is microprocessors and microcontrollers. Same digital electronics are doing this much. Fantastic, right? With the D flip-flop with the clock. This is what we have discussed so many things in long back. But the same D flip-flop and the field effect transistors and the pin and tri-state buffers are doing this much wonders inside the microcontroller. This we need to celebrate. It is a time for us to celebrate. Okay, so to conclude, at reset, the D latch must be logic 1. If the D latch is 1, then only the pin will be isolated from the latch through this driver field effect transistor. Hence, data present in the pin can enter the microcontroller, but data present in the microcontroller, that means data present in the D flip-flop will never reach the pin at reset. Hence, microcontroller is safe and the devices connected to the microcontrollers are also safe. It will never get affected by the junk value in the D latch. So while programming, we can make this port as an output port and then we can send out the data that can go to the pin, then it is much safer. Okay, so D latch need to be 1 to keep the port pin as input port. If the D latch is not 1, then port will act as an output port. That is very interesting. Now I can show you in the simulation because everybody can understand the theory, but while working, while simulating, you can do this. Because port 0 is logic 1. Now I am giving logic 1 to the port 0 pin. It is accepting, right? Now I am giving logic 1 to the port 0 pin, it is accepting. When I am clicking, it is becoming 1. When I am clicking again, it is becoming 0. Now, purposefully, I am making port 0 D latch as 0, 0. This is very interesting opportunity for all of us to experience how the port 0 works through the KEIL IDE simulator. The rest of the thing, you know how to write a program, you know Python programming, you know artificial intelligence, you know deep learning, you know machine learning, you need you know machine language, you know everything. But these are all the primary things where I need to, or we teachers need to make you to understand. Rest of the thing you do all wonders. That is why please observe this carefully. Now port 0, D, I am making the D flip-flop as 0 purposefully. Because I have made the D flip-flop as 0, Q will become 0. You see, Q will become 0. So because Q has become 0, Q bar will become 1. Because Q bar has become 1, this switch will be, this field effect transfer will be switched on. Because it is switched on, so then whatever is available in the D, which can reach the pin. For example, if the D flip-flop content is 0, so because the FET is switch on, because D is 0 means Q will become 0 and Q bar become 1. If Q bar is 1 means what? The transistor will switch on, so it will act as a short circuit. It will act as a short circuit means what? The pin is grounded. So when D is 1, that is when D is 0, the pin will also become 0 because it is grounded through this field effect transistor. Fantastic, right? If the D is 0, pin will become 0. Now it acts as an output port. From this discussion, it is very clear, right? So now what is there in the pin? Now you can see what is there in the pin, which can, so now it acts as an output port, right? Now it is acting as an output port. Now if you try to give the input, means it is meaningless.